Polyatomic ions. Dissect what this means. Poly, more than one. Atomic, atoms. Ions, charge. Right? Polyatomic ions are a group of atoms with a charge. And there are probably, I'm going to say 100 of them. Maybe give or take somewhere in that 100 range. And you only need to memorize, drum roll please. You only need to memorize 2, 4, 6, 8, 10, 11 of them. So 11. There's probably like 100-ish, and we're making you memorize 11. You're welcome. How do you memorize them? I don't care. Get them in your brain. Okay. When I was in high school many years ago, I had to memorize probably 60 of them, and I made flashcards. There's no real rhyme or reason. There's nothing I can really do to help you. You just need to, I put the name on one side, I put the ion on the other, and I got it in my brain. Ammonium, NH4 plus 1, right? And you need to be able to go both ways. You need to say, oh, NH4 plus 1, that's ammonium. You need to be able to say ammonium, that's NH4 plus 1. Now, I will give you a tip. Ammonium is the only polyatomic cation with a positive charge. The rest of the polyatomic ions are anions, and so they all have a negative charge. Ite versus 8. If it's a set of ions with an ite and an 8, the ite has less oxygens than the 8. So nitrite has O2, nitrate is O3, sulfite is O3, sulfate is O4. But there's no rhyme or reason for the number of oxygens or whatever. So my recommendation, unless you already have these memorized because some high school chemistry teacher made you memorize those, and if they did, then you can go back and thank them because they were a good high school chemistry teacher. If you don't have these memorized yet, you're going to need to have this out in front of you while we do this next bit. Now, I gave you this paper last night, so have this out in front of you. Don't worry about the strong acids and that stuff there. We're focusing on this right here. Okay, good talk. So these polyatomic ions throw a wrench in our naming system. Let's talk about why. Well, sometimes you don't have to do anything different. Let's start with that first. How about something like sodium nitrate? Cool. Sodium, find it on the periodic table. Sodium likes to rock a +1 charge. Cool. Nitrate, you're going to need to memorize it, but find it on that sheet for now if you don't have it memorized. Nitrate's one of those polyatomic ions. It's NO3 with a -1 charge. These two go together perfectly. I can take a sodium and a nitrate, and I can just go boop, and jam them together all willy-nilly, +1, -1. They were meant to be together. It's NaNO3. I don't need to do anything different here than what I have been doing. The problem with polyatomic ions is if you need more than one of a polyatomic ion, now it complicates things. For example, let's try to do calcium nitrate. If I want to do calcium nitrate, we find calcium. Calcium is an alkaline earth metal. It's +2. Nitrate, we just talked about it. It's NO3 -1. I cannot jam calcium and nitrate together all willy-nilly and make a neutral molecule. It's not going to work. Okay, why? +2 -1, I'm going to need 2 nitrates. Here's the issue. We cannot just keep doing what we've been doing because if I throw a 2 on there, that looks like 32 oxygens. And that's not what I want. I want 2 nitrates. So what do you have to do? If you need more than one of a polyatomic ion, you have to put that polyatomic ion in parentheses before you say how many there are. Polyatomic ions require us to use parentheses when we have more than one of them. So calcium nitrate, that nitrate got to go in parentheses, and then the 2. Give you another one. try ammonium oxide. Ammonium, take a look at your sheet. You won't need to memorize this. Ammonium is NH4 with a +1 charge. Oxide, find it on the periodic table. Oxide rocks the -2. I need 2 ammoniums to cancel that out. It's going to have to go in parentheses. Parenthesis NH4, parenthesis 2O. That's ammonium oxide. All right. Let me give you a couple here. All right. Hopefully, if you ever, if I'm going too fast, again, like can't see you. I don't know if you're done. So if you ever need more time, you let me know. So anyway, magnesium perchlorate, magnesium +2 perchlorate, ClO4 -1. I need 2 of those. That's Mg parentheses ClO4 parentheses 2. Potassium acetate, potassium +1. Acetate is C2H3O2 -1. That's a match made in heaven, folks. No parentheses needed. That's just KC2H3O2. Zinc cyanide, zinc, rocking the +2, cyanide -1. I need parentheses around that. I get a lot of people, they think, oh, I don't need parentheses on there. Here's the problem. If you don't use parentheses, that's just 2 nitrogens. But I need 2 cyanides. I need 2 carbons and 2 nitrogens. That has got to go in parentheses, and I get a lot of people that don't. If the last element in a polyatomic ion doesn't have a subscript, people think they don't need parentheses, but you do. Yeah, you do. It's polyatomic. And then iron 3 carbonate, that's iron with a +3 charge. Carbonate, CO3 -2, that's a swap and dropper. This has got everything. It's got a type 2 metal. It's got polyatomic ions. We got to swap it. We got to drop it. It's going to be Fe2 parentheses CO3 parentheses 3, iron 3 carbonate. All right. Hopefully that went okay. We did that. We did that. We did that. Here we go, folks. 1 to 12. Numbers 1 through 3, I want the name. Numbers 4 through 7, if I give you the name, I want the formula. 4 through 8. 9 and 10, go back, give me the name again. And then 11 and 12, give me the formula. So if I give you the formula, I want the name. If I give you the name, I want the formula. Oh, boy, folks. This is going to take you a solid 5 minutes. Okay, at least. So I'm going to write these on the board. Do your best. We'll go over them. That's how you learn. Good luck. That I can do that. So we crossed out, remember, 10 and 6. So another minute or two. Awesome. All right. Let's do this thing. So NH4NO3. 2 polyatomic ions. That's ammonium. And that's nitrate. That's ammonium nitrate. Here we have sodium. And SO4 is sulfate. And number 3, here we have a toughie. Here's the problem. That's mercury, and that's nitrite. The problem is mercury is a type 2 metal. So you can't just say mercury nitrite, because what mercury is it? You have to tell me the charge of that mercury. Well, nitrite's -1, but you got 2 of them. That's -2. This mercury must be mercury 2 nitrite. My guess is, because you guys are just starting out, maybe you're missing that 2. But it's a type 2 metal. Got to put that Roman numeral in there. Iron 2 nitrite. So iron 2, that's iron with a +2. Nitrite's NO2 -1. So that's FeNO2 2. Iron 3 nitrate, that's iron with a +3. Nitrate is NO3 -1. I need 3 nitrates, that's FeNO3 3. So you gotta be careful. Ite and ate makes a difference. Antimony 3 carbonate. Antimony 3, that's antimony with a +3 charge. Carbonate has a -2 charge. Swap it, drop it. Sb2CO3 3. Magnesium acetate. Magnesium's +2. Acetate is -1. I need 2 of them. Mg parentheses C2H3O2 parentheses 2. Number 9, copper perchlorate, but copper is a type 2 metal. I need to specify its charge. Perchlorate's -1, that's -2. That copper must be +2. This is copper, Roman numeral 2, perchlorate. Tin 4 perchlorate, that's tin with a +4 charge. Perchlorate, ClO4 -1. I need 4 perchlorates. Sn parentheses ClO4 parentheses 4. And finally, nickel 3 cyanide. That's nickel with a +3. Cyanide's -1. I need 3 cyanides to cancel that out. Ni parentheses Cn parentheses 3, nickel 3 cyanide. And there it is. How'd we do? You get 1 wrong, 2 wrong, 3 wrong, 4 wrong, silly mistakes, no idea what you're doing, I don't know. So, work on those polyatomic ions, start early. The sooner you get them memorized, the easier the nomenclature gets. There's good news. That's as hard as it gets. Ionic nomenclature with type 2 metals and polyatomic ions, that's as tough as nomenclature is going to get in here. Now, you take organic chem, you got a whole different system going on. The covalent and molecular nomenclature that we're about to do, that's going to take 10 minutes. And it's easy. All you got to do is memorize 10 Greek prefixes. So ionic nomenclature, way more difficult. That is tough. Tough.